Okay, Assalamualaikum. So, I'm Dr. Wan Nur Shahida. Okay, one of the lecturer for applied statistics. Okay, so this video it is for the chapter 1.1 only. Okay, for the 1.1 only, and then another lecturer will continue with the rest. Okay. First of all, welcome to BUM 2413 lah. Okay. So the chapter 1 it is about introduction to statistics. Okay. So chapter 1 it is about theories behind the applied statistic. We have only a few things that we calculate here. So don't ask your lecturer where is the calculation, because chapter 1 it is about theory behind that lah, behind of the applied statistic. Okay, so these theories will be used until the end of this course. So we have 6 chapter. So this theory will be implemented in the rest of the course until chapter 6. Okay. So, but we still have a few things that we need to calculate in chapter 1 lah. But most of it is a theory that we have to read, that we have to memorize, that you have to understand. Okay. So, the expected outcome of the chapter 1, you should be able to define the basic terminologies of statistics. So we have a few terms that we use in applied statistics. So those terms will be used until chapter 6. So you have to understand lah the terms that we use. Okay. So able to apply the basic step in the statistical problem solving methodology for the various application. Okay, so able to summarize and analyze data using measure of central tendency, measure of variation, and measure of position. Okay, and then able to relate the concept of accuracy and precision of the data using game of that. So the accuracy here, it is related to the measure of variation lah. Okay, so able to conduct the exploratory data analysis that include numerical data analysis and various graphical display. So here we will discuss a lot the box plot. So it will be calculation in this part lah. Okay, so able to plot and interpret the normal probability plot. Okay, so also some calculation here. Okay, so we go to the next one. Okay, so content. Okay, so we have 5 subtopic here, but we cover the 1.1 statistical terminologies. Okay, so 1.2 is a statistical problem solving methodology. So this one it will be implemented in your assignment letter. So make sure that you focus lah. Okay, so review on the descriptive statistic. So calculation we start here lah. Okay, measure of central tendency, measure of variation. Okay, measure of central tendency, it is more to the it's like mean, median, mode. Okay, variation is a probability. Okay, variance, standard deviation, and then we have measure of position, quantile, if you ever heard about that lah. Okay, so descriptive statistics using Microsoft Excel. So we explain how to use the Microsoft Excel to perform the descriptive statistic. Okay. Okay, before I forget, for this course we will use Microsoft Excel as a added software. Okay, so in fact your assignment letter you have to use a Microsoft Excel. All the values that you need for your assignment must be using Microsoft Excel, or the graph you have to plot by using Microsoft Excel. Okay, and then we have the exploratory data analysis, or EDA. So we will discuss what is outlier, how to calculate the outliers, and then we have the box plot, and then the last one we have normal probability plot. So normal probability plot, it is a graph that we use to check whether the data that we have is a normal or not. Okay, So we go to the 1.1 statistical terminologies. Okay, so you have to define the meaning of statistic, population, sample, parameter statistic, descriptive statistic, and inferential statistic. Okay, so we discuss the importance of statistic in the daily life. Okay, so what is statistic? I think all of you well known what is statistic. Any numerical value represents something. That's statistic. Okay, any numerical value that represents some issue, whereas some issue lah, some issue, it is statistic. Okay, for example here 10,000 parents in Malaysia have chosen stem life as their trusted stem cell bank. Okay, or let's say that we have in our class we have about 50% of the student wearing glasses, or we can say that 5 of 20 female student wearing glasses. Okay, so that's statistic. Okay, or we can say that 30 students in this class are male, for example. 20 students in this class are female. That's statistic. Any numerical value that represents something or some issue or some characteristic, it is a statistic. Okay, so simple lah. Okay, easy to understand what is statistic. Okay, so you can find statistic in many platforms. You have radio, you have television, you have the newspaper, or you have the magazine. Or nowadays we don't read the newspaper. We don't read the newspaper, but we read online lah, the newspaper through the online. So you can find through the online. You have in your IG, Facebook, and so on. Okay, you can find the statistic. Okay, but scientifically, okay, statistic is a sciences of conducting studies to collect, organize, summarize, analyze, present, interpret, and draw conclusion from the data. Okay, so you will collect the data, organize the data, summarize the data, analyze the data, present the data, interpret the data, and then draw conclusion from the data. Okay, so what is the data here? So data is any values. So it is observation or measurement that have been collected. Okay, observations or measurement that have been collected. Observation, it just we observe that data or we measure that data lah. Measure here, maybe we use some tool to measure that data. Okay, for example height, so we need to lah. Okay, to measure that data. Okay. Okay, so data, for example here, what we are talking about the weight. Okay, so the data that we collect to represent the weight will be in kg. Okay, so data, what is your data influenced by what is the characteristic here? Okay, so the weight here, we call it as a variable. Okay, so what kind of data that you have influenced by the variable that you have? So weight, the data must be in kg. So like 50 kg, 60 kg, 80 kg. So this is a data. Okay, so if you have numerical data here, we can call it as a quantitative data lah. Okay, you will discuss further later lah. Okay, or you have the non-numeric data. For example, we are talking about the gender in this class. Okay, gender. So how the data will be collected? Okay, it will be like, okay, student 1 is a female, student 2 is a male, and then student 3 is a male, and then student 4 is a female. So this is the data that we are going to collect. So this kind of data we call it as a qualitative. Okay, we discuss in further lah. Okay, so what is the data here? Will be influenced by the characteristic that we want or the variable. Okay, so collection and analysis of data are the most important part in the research methodology. Okay, so how good is your data will influence the rest of your research. Okay, will influence the result, will influence the conclusion that you obtain, will influence how you are going to solve that problem lah. Okay, so basically this is what you are going to do for your assignment. Okay, you start with the collect the data and then close with the conclusion. Okay, so collection and analysis of data, so it is important in the research methodology. So you will discuss later how to collect the data, what method that we need to use. Okay, so how we are going to collect the data must be represent the objective of our research lah, so that the data we will have a good data lah when we collect the data. Similar, when we analyze the data, we have to make sure that we choose a correct method that reflects to our problem. Okay. Researcher must have a basic knowledge of statistics before starting any research or study involving data analysis. Okay, so statistic is also used to analyze the result of survey and as a tool in scientific research to make decision based on control, experiment, estimation, prediction, and quality control. Okay, so the next one, why we need statistics. Okay, so basic knowledge of statistics is needed in any discipline or any field of the research of study. Okay, in almost all fields of human that involve data analysis, the method of statistics allow the researcher to design a valid experiment and finally draw a reliable conclusion or interpretation from the data they produce and analyze. Okay, for example, in sport, statistician may keep record of the number of successful kicks a team score during a football season. Okay. So in public health, a doctor might be concerned with the number of child who are infected in. So we can change here. Okay, we can change here what COVID-19. Okay, so doesn't matter what you are going to be, an engineer or scientist, what else? Accountant or so on. If you will be working in the bank sector. Okay, doesn't matter what you are going to be, statistics is very important lah. Okay, everything that we try to prove must be supported by the data. Okay, must be supported by the data. Okay, so once you have the data, doesn't matter how small it is, how large it is. Nowadays we are talking about the big data. So it doesn't matter how small the data it is, how large the data it is, you need statistics to analyze. Okay, and then come out with the good conclusion that reflects to your problem. Okay, nowadays we have COVID-19. Okay, so we need statistics to present the data that Dr. Hisham present to you. It is statistic. Okay, how many case today, how many death today. Okay, that statistic. Okay, so we need statistic method to analyze that, the average of case per day, whereas the average of case that heal per day. Okay, we need statistic. At least we don't ask much, but at least you can calculate, for example, the sympathy mean, median, variance. You can discuss the probability of your data and so on. That's why we need statistic. Okay, doesn't matter what you are going to be. Okay, once you have the data, automatically you need statistic. Okay, so what we call scientifically, why we need statistic? To describe the relationship between variables. Okay, so here you can read lah the example here, or let's say that we have the variables that we have, weight and age. So how we are going to relate these two? Okay, in chapter 5, you will discuss the simplest things for the relationship, which is a correlation coefficient. Okay, small r. So using this value, we can describe or we can talk about the relationship between these variables, or maybe more variables. Okay, we can describe or we can describe whether they are related or not to each other. Okay, if they are related to each other, how strong the relationship, how much they relate to each other. So we can know that one based on the correlation coefficient. Okay, so scientifically, variable is a characteristic or attribute that can assume different value. This value are the data. Okay, it is called random variable if the value are determined by chance. Okay, so the weight and age here, they are variable. Okay, the data that we collect to represent weight, the value that we collect to represent weight and age, they are data. Okay. Okay, the second one, why we need statistic, making better decision in the face of uncertainty. Okay, simple say everything that when you okay, let's say that you are engineer. Okay, any engineer lah. Okay, you want to inform your boss, oh, we need to change the machine, for example. We need to change the machine A to the machine B. So why we need to change that? You have to support with the data. Oh, I collect this data and analyze data and found out that machine A is not appropriate to use anymore, or the quality of the machine A is bad. Okay, so how do you do that? You compare with the data from machine B and you analyze and so on, and then the conclusion, machine A is not good to use. So your manager will change it lah, because you have the data to support it. It is not just talk. Okay, you're not just saying that it is not good. So how it is not good? How do you know? So you have to support with the data. So to make a better, to make a better decision. Okay, change the machine, for example. Okay. So 1.1.3, population and sample. So population and sample here, it is a very important here. Okay, so population is a complete collection of measurement or outcome, object or individual under study. So population divide by 2, whether you have tangible population. Tangible means that finite number of, we have a total number of population, or you have the conceptual or intangible. Okay, we have unlimited number of subject. We have uncountable number of subject, infinite number lah. Okay, and then you have the subset, you have the sample, a subset of the population that is observed. Okay, let's see the example. It's a new slide. Okay. Okay, let's say that the example, let's say that we are talking about the simple thing, monthly, not monthly, okay. monthly expenses by UMP student. Okay, by UMP student. So clear to say that the data will be collected from UMP student. So the whole UMP student. So here UMP student. Okay, so the data will be collected from UMP student. So the whole UMP student, it is a population. Okay, the whole the complete collection of measurement, outcome, object or individual under study. So where the data come from? Okay, the whole collection of where the data come from. So monthly expenses by UMP student, the data are from UMP student. Then the whole UMP student, it is our population. Okay, so we have about, for example, that we have 10k of UMP student. So we can get that number. Okay, we can get a total number of UMP student. Then it is a tangible. So this population, tangible population, finite number. Okay, infinite number, for example, we do IT more to the zoologies research. We are talking about the fish, number of the bacteria. It is an infinite number lah. So if you have infinite number of population, it is conceptual. Okay, so let's say that we have about 2 weeks to collect the data. So it will be impossible to collect from 10k of student. So what we do, we just collect from a part of UMP student. So subset of the population. Let's say that from fees. We just collect from fees students. So fees here, it is a sample. Okay, you can have another one, FKKSA for example. So also the sample. Okay, PSM, Pusat Sains Mathematics, also sample. Okay, a part of the population, it is a sample. Okay. Any numerical value that you calculate from population. Okay, any numerical value that we calculate from population. Okay. So let's say that you calculate the average or the mean. Okay, whereas the one that we always calculate, variance, standard deviation. Okay, so any numerical that we calculate from population, we call it as a parameter. So parameter average, parameter variance, or parameter standard deviation. So here we use mean lah. It's more clear. Mean. Parameter mean. Okay, variance and standard deviation. So any numerical value that you calculate from population, it is parameter. Okay, so we call it as I will wrote here population mean, or true mean, or hypothesized mean, also parameter lah. So we have 3 terms that we use here: true value, population value, or hypothesized value. They are parameter. Okay, any numerical value that you calculate from the sample. Okay, similar, let's say that we calculate mean, variance, and standard deviation. We call it as a statistic. Okay, so another terms that we use: sample mean, sample variance, sample standard deviation. So how do we differentiate population mean and sample mean. Okay, both are mean. So how do we differentiate? We use notation. Okay, how do we inform audience? Okay, how do we inform the reader? This is population mean, this is a sample mean. This is population variance, this is sample variance. So how do we inform the reader? We use notation or symbol. Okay, population mean, we have mu, population variance, sigma square, population standard deviation, sigma. Sample mean, S bar, sample variance, S square, sample standard deviation, S. Okay, that's how we do. So I hope that you understand lah. Okay, so you can read from here, okay, in detail. Okay, so we have the example 1.1 here. Okay, so the travel agent claimed that the average number of rooms in large hotels in Pahang is 500 and the standard deviation is a 165. A sample of 7 hotels in Genting Highland is selected and the average number of rooms is found to be 435 and standard deviation of 15. Okay, so the data, okay, first, what is the variable? The characteristic here. So the characteristic here we can define based on, okay, average, the one that we calculate. So average of what? That's your variable. So here, number of room. Okay, large hotel in Pahang. So the data from the large hotel in Pahang. So population is all large hotel in Pahang. Okay. The most important word here, all, to show that it is a complete collection. So all large hotel in Pahang. Okay. What is a sample? A sample of 7. A sample of 7 hotels. So it is clear that the 7 hotels here is a sample. So that's why you have sample 7 hotel in Genting Highland. Okay. So population here, large hotel in Pahang. So we can count how many large hotel in Pahang. That's why it is tangible. Okay, variable, it is a number of room just now. Okay, how we define the variable? We calculate something from what? We calculate average from what? We calculate variance from what? That what is your variable. Okay, so the average number of room in large hotel in Pahang is a 500 and standard deviation of 165. So all the large hotels, okay, in Pahang, 500. Okay, so large hotel in Pahang, it is a population here. All the large hotel is a population. Automatically, values that present population here, they are parameter. Okay, so you have mu here, you have the sigma here. Okay, a 7 hotel is a sample. So any numerical value from this sample, it is a statistic. So average 435. So automatically S bar, standard deviation of 50, it is your S. Okay. So for the better understanding, you can do the exercise 1.1.3 lah. Okay. So you can discuss with, try to do first and then you can discuss with your lecturer lah. Okay. Okay. So descriptive and inferential statistic. Okay. So descriptive statistics include the process of data collection, organization, classification, summarization, and data presentation obtained from sample. Describe the characteristic of sample. Okay. Inferential statistic involving a process of generalization, estimation, hypothesis testing, prediction, and determination of relationship between variables used to describe, infer, estimate, approximate the characteristic of target population. Okay. Simple word, Descriptive here. Okay, descriptive here, where you have confirmed number about something. Inferential here, we just estimate or we do the conclusion. Okay, I don't know what happened. Okay, for example, descriptive statistic, 10,000 parents in Malaysia have chosen Takaful Insurance as their trusted life insurance agency. So it is confirmed that we have 10,000 of parents in Malaysia. So it is descriptive. Here, the death rate of lung cancer was 10 times higher for smoker compared to the non-smoker. So what we do here is conclusion. It's like conclusion or inference. We say that the death rate for the lung cancer was 10 times higher for smoker compared to non-smoker, but we don't have the confirmed number. How many smoker? How many non-smoker? So it is inferential. Okay, let's go to the okay. Okay, so this is the what we call the overview of the descriptive and inferential statistic. We start with the data collection, organization. Is the information from sample? If yes, use a sample information to make inference about the population. Okay, and then draw conclusion about the population characteristic. Okay, so we use sample as a information to make inference about the population. So inference here, the word inference here, that's why we have inferential here. Conclusion here, that's why we have inferential. So inferential is we make a conclusion or inference about the population. Okay, is the information from sample? If no, use a census data to analyze the population characteristic under study. So census data is a bancian. Okay, usually if you have data bancian, then it will be confirmed number about something. That's why it is descriptive. But when we use the data here to draw a conclusion about the population, when it is a conclusion, automatically inferential statistic. Okay, let's see the exercise. Average cost. Okay, decide whether the statement describe the descriptive statistic or inferential statistic. Average cost of a wedding is nearly 10,000. The keyword is nearly. Nearly, it is not confirmed yet. It is a 10,000. So it is inferential statistic. Okay, if we don't have the word nearly, then it is descriptive statistic. For example, the average cost of wedding is 10,000. So it is descriptive statistic. Okay, you can do for the rest of the exercise. Okay, we go to the 1.1.5, the role of computer in statistics. So there is two software tools commonly used for data analysis. One of them is a spreadsheet. So we are using spreadsheet, which is a Microsoft Excel. Okay. So for the whole course, it will be application. It will be application of Microsoft Excel. For every topic, we have the application of the Microsoft Excel. How to get that analysis by using Microsoft Excel and how to calculate manually lah. Okay, but your assignment letter all must be using Microsoft Excel. Okay, and then we have the statistical package, the one that widely used. We have the R programming, we have the SPSS. Okay, and also Minitab here, but Minitab here is license. We have to buy the license. The open source here, most of the researcher use the open source, which is R. So R is the open source software lah. Okay, you can get through the online. Okay, so in the Microsoft Excel, we will use the data analysis application. Okay, if you open your Microsoft Excel, okay, in tab data, you can find data analysis. If there is no data analysis in your Microsoft Excel, then you have to add in here. Okay, go follow this tab to add in your data analysis. So in your data analysis, we have this ANOVA in chapter 4 letter. Okay, we have, this is chapter 3. This is chapter 1 letter 1.3. Okay, we have the histogram for your assignment. Okay, so you need to have the data analysis in your Excel. Okay, so this is the step how to add in the data analysis if there is no data analysis in your Excel. Okay, you can find here the tab data. So data analysis tab should be under the data. If there is no data analysis, then do the add in. Okay, so this is the step. Okay, so after you have the data analysis here under the data analysis, then you can use lah. Okay, so you can try in your own computer lah for the data analysis. Okay, I think that's it for the 1.1. Another lecture we continue with the rest. Thank you.